Alrighty, cool. Hey everyone, excited to be moderating this panel today. My name is Benji. I am an investor at Archetype, which is an early stage venture firm. Very, very excited to be grilling all of these solvers today, many of which who I know, but some of which I don't. Maybe I'll let them kick it off with an introduction on themselves, and then we'll get right back into the questions.
Hey everyone, Felix from Altex, now GlueX protocol. Been solving for Chaos Swap for the last 2 years. Been solving for other protocols. Yeah, we were the first solver on Chaos Swap, external solver, and since then, yeah, intents have become more of a thing, and now we have more to solve. So very good, and now GlueX is just abstract, like formalizing that into a protocol that can be scaled across chains, and that's what we do.
Hello, Kevin, co-founder of Kalani. Kalani is we're not a solver, but we're the infrastructure for solvers and where you build solvers. So Kalani is the infrastructure where instead of building solvers from scratch, you can just deploy solving modules. We call them modules, right? Like code, like smart contracts, to Kalani, the blockchain. And then you can run Kalani node as your solver. So it's just a new way to build solvers. And for all the modules deploying Kalani, they can also compose with other modules also on Kalani. So that's what we do.
I'm Connor Howe, one of the co-founders of Enso. We built an intent engine that's able to solve many different types of intents, ranging from any arbitrary state, tokens, DeFi positions, and NFTs. This is currently consumed by many intent networks, including CowSwap. And our vision for the future is that all developers can start building intent-centric applications using Enso.
Hey everyone, I'm Tanay. I work as a researcher at Propellerheads. We build solvers and products to help users get fair execution on chain. One of our first products is a solver that's currently live on CowSwap, and please excuse me for the sore throat. Yeah, we compete on CowSwap, One Infusion, and Uniswap X. And yeah, we'll be releasing some products soon for users to get private trade execution on chain as well. And yeah.
Awesome. Thank you so much, everyone. Maybe one question to jump in here. What makes for the best solver? Like, how would you assess that? Can you break it down quantitatively, qualitatively? How can we get familiar with that?
Spend 16 hours a day behind your laptop and add new protocols, build custom algos, have the best speed performance. Constantly have analytics of what other solvers are doing, learn from their behavior, and constantly improve. So 1, price execution. 2, gas. 3, distribution of what's available in your solver set.
Any opposing takes? Well, one question maybe to narrow it down.
Take.
Go ahead.
I'm not sure it's opposing, but well, I think it's like this is more of a big picture sort of take, right?
Yeah.
We know what's bad for solvers, which is monopolizing and sort of all integrating solvers and just take everything, and that's bad.
Why is it bad?
Because then they can extract value, right? So like whenever there is...
Isn't that capitalism? Isn't that how it works?
Well, you can always... you encourage sort of the bazaar versus cathedral, right? So if the bazaar have more of like an ecosystem and diversified and more participants, you lower the entry, lower the barrier for entry instead of raising the barrier of entry, right? You have a healthier ecosystem if you go that direction.
So you're saying Kalani is a non-for-profit or what?
Social good?
We are a blockchain, just like...
Yeah, blockchain you can, I don't know. I mean, it depends on how permissionless you are. If you're just running a blockchain, are you going to be pushing the gas price up so that I don't know, like your validators become very profitable? When who is running the validators? Like where are you pushing the profits?
Token emissions.
Well, I mean, again, it's like same as Ethereum, right? So like, there's nobody that sets the gas price for Ethereum. It's all demand and supply, right? So, I mean, you also don't have to use Ethereum. You can use other platform too. But it's a coordination place, right, for that to happen, to allow anybody sort of come to it at a selling point to like for us to solve.
What's
So-
the benefit of having 1,000 solvers instead of 10 that do their job really well?
Let me redirect the question. Do you feel like the current marketplaces upon which solvers compete to execute a user's intent compel you towards better user outcomes at the moment or worse user outcomes at the moment?
Completely better user outcomes today. It's just competition. You need to be delivering the best. Auctions, intents and auctions just enable, like, if you are the best, you're going to take it. If you stop being the best, somebody else is going to take it. So yeah, that's how it works. And it really is up to you to offer the best, and you're rewarded for that. Yeah, so it's really, I guess the only question is, the quality differs. So if you go for CowSwap, you go for Uniswap X, or you go for one institution, you're going to have different quality because they all have different solvers. So really they're like, yeah, it's not a question on whether we are like they're being correctly incentivized and like it's getting better. It's like, I think if there is a problem is the question of unification of soul compute, assuming that, like, I mean, I guess at some point there's going to be, maybe there's one big solver that manages to integrate everywhere, and then you have that guarantee that you're being exposed to the same quality everywhere. I think it's just very hard, assuming that there are going to be multiple rollups, multiple DApps, some of them not attractive to that very big player. So yeah, I mean, the question is more like the accessibility to quality, but the incentives are, I guess, correct.
I think that's one of the challenges, right, as a solver. It's like, do you spread your wings and you go too far and you go to like supporting 50 different intent networks? People think that's easy. It's actually not. I think the underlying infrastructure can be replicated to some degree, your indexers, your algos, your integrations. But each auction, each protocol has different edges. You know, for example, Copium Capital on CowSwap, he only does Cow. And that's why he's number one, because he just focuses on that protocol. If you're building all of these integrations into Uniswap X, when it's Fusion, Bring, Aperture, someone's calling me, cancel that. These are moving targets. The code base we had to understand CowSwap 8-9 months ago is very, very different now. These are very, very premature products that are accruing immense value, but they're changing so much because it's a new industry. So if you're doing 50 different protocols and solving for them, yeah, I mean, you need like a 25-person team to be able to do this and to do it properly. It's just a consideration of spreading wings too far too quickly.
Maybe to add on to that, it would be helpful to take a step back and better define the types of solvers that exist. Connor, you pointed out that many are specialized on specific domains and are better suited towards achieving and winning those kinds of games. One of the framings that I've always thought of is there are solvers that take on liquidity risk and there are those that don't. There are arbitrageurs and market makers. But maybe there is a better, more helpful framing in mind to differentiate what the different solvers are and their core competencies.
Maybe someone else can go. I think I've already taken enough time.
So yeah, you rightly pointed out there are usually two kinds of solvers that you see. Ones that take on inventory risk and ones that focus on routing. Well, we might want to argue that these roles can be further decoupled into more granular actions, saying, you know, let's build a solver that focuses on lending, focuses on perps. While that sounds exciting, we are yet to see such complex intents emerge. But yeah, maybe, you know, Enzo builds a series of actions.
SEM-IO and 10X, that's what they do.
Yeah, but
Aori, they do lending.
yeah,
Sim and 10X, they're doing perps.
yeah, sure. But we will, yeah, as you're right. Okay, fair. So we will start seeing that decoupling come in soon. But I would argue that there are avenues where a solver could integrate, let's say, a lot of these market makers where the risk of having your own inventory goes down significantly. There are a lot of protocols being built out there to minimize solvers taking on this inventory risk. And at that point, you may not need that decoupling between solvers having inventory, which is at that point you're just a market maker, and then if you're focusing on routing.
One really interesting thing you bring up is this liquidity topic. I think we were on a panel the other day talking about, do we hold liquidity? No on solvers actually holds their own liquidity. And maybe 8-9 months ago, we all went through a similar thought process independently, which was we're going to need to, and nobody has. Everyone's integrated RFQ providers, they've integrated the market makers because it's very clear that it's a whole different business, right? This is risk management, this is on-chain routing in algos and edge and MEV. That's just pure inventory management and hedging.
Yeah, so we have a very different sort of definition or view on solvers than probably most panelists here. So in our view, anybody or anybody that can contribute part of the solution is a solver, right? So if you can facilitate like a cross-chain transaction, that's a solver. Some people call that relays, some people call that cross-chain swap solvers. But in our view, that's a solver. Somebody that can do like a fill, like call swap trade, that's a solver, right? Somebody that can provide indexing as a service to index like 100 AMMs on Ethereum, that could be a solver. They can provide part of the solution. Like in Kalani's model, they will work with other solvers to, if you provide liquidity, that's also a solver, right? That's a liquidity solver because you can also be part of the solution as well. So it's more like, in our view, it's more specialized in terms of what you can do. And then, what we do as a platform is to bring everybody together to sort of, to fill intents.
I see. So what comes to mind that might emerge as a result of the previous topic, which is that like intents might become more complicated. You might mix in a swap and a borrow and a lend across multiple chains, and that might require an edge in terms of your algos and your perception of the world and the speed and ingesting it into your model to suggest an outcome. And very naturally, my head turns towards a visualization of like a very, very powerful computer that is like participating in some sort of like combinatorial auction that has to like be quite like compute intensive, and that like not everybody in the world might have the ability to have access to those resources, the bandwidth, the compute, and the algorithms. And so like, Kevin, you're talking about a world in which it doesn't necessarily have to be one computer that gets to that solution and participates in some sort of complex combinatorial auction to fulfill an outcome, but that you can actually have multiple little computers specializing on little parts of the answer and still get to the outcome. So why is it that way and not the other? Like, what is it specifically about what you're doing that thinks that it won't just be one big powerful computer?
Yeah, I mean, so first of all, I mean, intents are very, very expressive, right? So I think we're only touching the tip of the iceberg in terms of what intents can accomplish. I think most of the panelists will be, agree to this. I mean, same with blockchain, right? So in blockchain in general, we're also, looking for new use cases and whatnot. So as you make intents more complicated and more expressive, then you also need to make solving more complicated. And this is kind of like two sides of the same coin, because if we don't have complicated or sophisticated ways to make solving more composable and more expressive or more capable, then you can't, I mean, developers won't make expressive intents because they're just not going to be solved. Then nobody's going to build them. So only you can sort of work on both sides of solving and intents in a way that sort of bottom up and then like the bazaar style, right? So the cathedral, you don't have to, go BD 5 different or 10 different solvers and try to say, hey, can you solve for me? Can you solve for me? And we want to make sure that also I have to stitch them together, this cross-chain relay plus, trade filler so that I can express in my wallet a certain type of intent to the users. Otherwise, I wouldn't. That just become very, it become like the hurdle is very high for most like small startup teams. Whereas if they could, incrementally just express the solving capacity they want to be able to fill, you just fill in the missing part. Then it's much easier for these apps to start developing and get users and get traction. Sort of feeding on the demand side, right? And then we can have better solvers and serve users better, so the entire intent space can grow.
I can add on this one. So I think you're gonna have both, right? You're gonna have services to create solvers. You're gonna have maybe the INSO intent engine is kind of like a master solver that people add to then create one solver for all. I think you're gonna still have specialized teams like Propeller, because it kind of all combines together to then fulfill a better intent. For example, if you're gonna use a service that aggregates all of these different intent networks and you're running your infrastructure and you're listening to that, you're losing edge. You're losing a lot of edge by doing this. So we're still going to have these isolated teams. We have a similar vision to Kalani in this regard of, we call them actions. So people can contribute actions to the INSO network. And an action could be how to lend on Avi, how to borrow, how to swap, and so forth. And this goes into what we call a shared network graph. And all of this information is stored in one place. And then the other participants are called graphers that will fulfill this intent by then traversing all of these actions and then combining them together to then create one call data. But to kind of answer your question, I think we're going to have all different types. And I think that's great. That's the whole point. Users get the best possible route, and that's the whole purpose of intents.
I actually have a question to add to this. So when we start decoupling a lot of these roles in a complex intent, when do you start moving between becoming too rent-seeking versus adding any efficiency? Because if for every small action there is a solver action happening again and again, there is value to be extracted at each layer. And when does it start getting detrimental versus it being good for efficiency and price discovery?
So you mean, like, for example, if you need to get to this endpoint and you go through like 5 different hops, and those 5 different hops are contributed by 5 different people?
No. I mean, the 5 different hops are fine, but when we, let's say, are coordinating between like 3 different solvers for a complex intent, when do you need 3 solvers which get the job done versus needing, let's say, 5 solvers, and you further break the intent into even more granular things? And there is a line where you start becoming rent-seeking versus actually adding value. Like, I'm just curious, how do you guys think about that?
Time. Really depends on timing. Purely timing. I mean, timing, and that's the purpose of the auctions on the top layer, right?
Yeah.
So the mechanisms that then would use stuff like Kalani or ENSO, they would then define the time barriers of responding, and also if this solution is even competitive to others. So, yeah, I mean, if you're going to go through like 20 different solvers for like one action, yeah, your response time is going to be like 15, 20 seconds. So there is an extent of a limitation here. But, yeah.
Yeah, I think one of the most important factors to consider here is, if you go to these sort of 20 steps or 5 steps of solving, if you want to use something like a greedy algorithm, it's actually pretty dangerous, right? Because you say, okay, for this, I'm prescribing like 3 steps. And the first step, I'm going to find the best solver. And then the second step, I'm going to find the best solver. And the third step, I'm going to find the best solver. And then the first step, okay, you solve this, and I'm going to give it to the second solver. But the problem is, what if the third solver does not come through, or the third solver just, like, they lose liveness and they just say, oh, I'm not going to solve this anymore? Then what's going to happen for the first 2 solvers? So, like in our view, this problem need to be. I mean, there are 2 things, right? So there's like this sort of like a greedy algorithm type of solve. Like you have multi-phase commitments. This won't work because of this problem, because they can't do global clearance, right? So what needs to happen is you need to find out like what are the possible the different set of solver need to propose their solutions. And think about, like, we talk about auctions, right? It's more like there can be multiple auction houses, and then these auction houses can have their own solvers, or they can, these solvers can participate in different auction houses. And when intent comes in, different auction houses may have a different clearing price for a same intent. But then only one of the auction houses will get the right to clear the intent, because that's more sort of aligned with the preference of the intent itself, right? So in this way, in the sort of more multi-stage RFQ and auction paradigm is more about solvers competing with each other in the auction house, right? Like in Kalani's phases, auction houses compete for intent. So it's a different sort of flip the paradigm here.
If you're calling for each individual hop, that will not scale.
We're not calling them. They emerge themselves, right? So they runtime assemble, and then there's only one single auction house that can spend the intent.
You've got auctions inside of auctions.
Yeah, so we build an auction house for the auction houses.
Yeah, but all this happened in state channels, right?
So-
So they're not on chain. All this happened on state channels.
I mean,
So there's only one that gets the land.
right, so I'm just trying to understand what, so you are saying you are having this auction house that's going to receive the proposal from every of these different specialized solvers. Is that what you're saying?
Yeah.
And that auction house is going to basically pull together the solution, like the complete package?
Yes.
And so that auction house has to understand every single solver optimally in a way that,
Yes.
so that auction house could generate those solutions as well itself by its own, right?
Not generate. It's basically sequencing. The auction house is basically like a sequencer, right?
Yeah.
It's
so
an
that auction house-
intent-centric sequencer. So
Right.
we see auction houses as sequencing solvers. It's also a solver. So this is like all solver collaboration all the way down.
Yeah, I mean that auction house. Okay, so that auction house will need to understand each of the in order for it to select either of the proposals on those niches, it's going to have to understand each of the profitabilities of those, right? Assume like the
Yes.
utility, the surplus of them.
Yes.
My only way to understand that is either I know how to generate that solution myself, so that I know the value of that thing.
Yes.
As I could have generated that myself, because if I know how to generate, I can also choose among them, so I can be a specialized solver. The alternative is you have another layer separated which verifies each of those and tells
Yes.
me, yes, by the way, that one is the right one.
Yes.
Okay, this is a lot of overhead everywhere.
Yeah, so this is why we use formal specifications, right? So everything can be sort of statically analyzed instead of simulated, right? So like at runtime, you know which ones, like for solvers, they will know which auction houses they can be part of to contribute solutions. They can concurrently contribute to multiple auction houses, so to speak. And then all this will clear at the same transaction on chain.
To maybe actually dig into what you just said in the context of a broader discussion on solvers is there is this movement towards infrastructure specifically tailored towards giving solvers better guarantees as they compete in an auction, right? That could be offered by a proposer that is giving a solver a pre-confirmation about what might be included within a certain piece of block space. It could be something like some sort of clearing system that maybe might guarantee a certain price that things might get executed at, an inventory management system that offers a certain amount of liquidity to a solver. Which one of these tools do you actually find to be the most helpful to you as you compete in auctions? And like from first principles, like what makes the most sense at the bottom part of the stack to give guarantees to solvers at the block space level?
Price.
Price.
I built this call data. I know with 100% guarantee on the next block it's going to sit on that. How to get to that point? Yeah, pretty tricky. I mean, that's how you use market makers. You could build some probability analysis, go into all the mempools, sniff all the transactions, check out what impacts that can have on liquidities, what generally behavior these searchers also do. But again, I don't think most solvers are doing that as of today.
Well, maybe to dig into that, like, have you already gotten to the point where competing protocols and systems have come up to you and being like, hey, we have this thing that can give you better price guarantees as you compete in these auctions, maybe like pre-confirmation of sorts on the price you're able to get. Have you already been part of these discussions with protocols, and have they been interesting to you or not really?
Yeah, there are.
Tell us more. Yeah,
there are situations like that. Yeah.
Okay. The solvers do not want to talk about the pre-confirmations.
It's a solver tag. Pre-confirmation is a solver tag.
What about?
I mean, you can say it's a preferred. You could express it as a pre-conf, or like, I mean, that's just a formal way. If you want to have that confirmation on chain, or most of the time, I mean, it just works informally as way, right? Doesn't need to be a blockchain verified confirmation, which is our relationship, it works as well. So whether you have a good relationship with a team, they see, they trust you, that's all.
And in this context, relationship with the team would imply relationship with the specific validator side of a blockchain that you might want to include a transaction in, correct?
Yeah, like that, or on the other side, somebody that enables, like, yeah, on the liquidity side as well, I'm talking about, right?
Got it. Cool.
Yeah, like getting a discount that nobody else has, right?
Yeah.
So yeah, it doesn't need to be on the settlement layer, right? It can also be on the liquidity layer that you get at that edge. Yeah.
Yeah.
I'll just put a little plug. Arrakis. Arrakis does this.
Shout out to Arrakis. Maybe one more to close it out, and this was mentioned maybe halfway through this panel, but you talked about and I don't know whether it was an inability or just the lack thereof of solvers actually holding inventory, and that was something that was going to have to change. Does this tie into the regulatory environment at all? And do you have any thoughts on how that might impact the future of solving to come?
At least for us, it's a matter of focus. We want to be more product oriented and want to ensure that we build things for users. But there are two ways to go in this, right? Like you could be product oriented or you could operate as a trading firm, and that is also a completely viable path for whoever wants that. But sure, as far as regulatory reasons go, I guess it boils down to personal preferences. We did experiment with it initially, having our own liquidity, but again, it was a distraction for us. And in the long run, we also see a potential future where the edge from having your own inventory is not as much, and hence the bet that we have taken so far.
For us, I mean, we're trying to abstract how to interact with the chain itself on many different layers. That's why we position it as an intent engine. D-Bridge, DLN trade, that's a market maker behind that's holding their own inventory to be able to do this. Will we ever go into our own inventory? Most likely not, because we're just part of the stack. And this modularity thesis, in a way, you can combine different building blocks together, similar in the cake framework. And we don't feel that's us. We know people are doing this and they're doing it great. You need to relearn everything from scratch, how to do this, and it's a waste of time. Collaborate with somebody that already does it, and then create the frameworks together.
Yeah, I mean, for us, again, we see, liquidity or inventory also as liquidity solvers. So people that provide liquidity can express their liquidity preference as intents, right? So say, okay, I'm providing USDC. I'm willing to be traded between these 12 chains. Anybody can sort of moving around for these 12 chains, as long as they pay me like use fee or like 10 bips or 2 bips. It's up to the user, to the solver, liquidity provider. And then again, as long as their preference or their intents can be also recognized by the other solvers, then they can collaborate, right? So I think it sort of remove the solver sort of on the hook of, we're carrying inventory, we're moving money around for people, and then maybe there's regulatory risk. But in this way, it just, some other people just permissionless providing liquidity or inventory that allows the solver to tap into them at runtime with sort of expressed like a usage contract. This is how you can move my liquidity if you and me can come to agreement. So it's collaborative solving, yeah.
Yeah, I agree with Kevin. Yeah, that's what we are doing as well already. So yeah, more around creating policies or protocol to incentivize the liquidity. I mean, somebody else provides it. You just create infrastructure. Don't see us. I mean, always the one pain. I mean, that I won't say that, but the one difficult thing here is centralized exchanges. I mean, they are just off chain. That's the real reason why anybody cares about holding inventory today. Otherwise, we just express it as a liquidity pool on chain. So whether we are gonna do that competing with already existing infrastructure that I think everybody just, I mean, everyone knows that it's just hard. Like, there's a lot of inventory risk. So I rather try to wrap my head around, like, 100 times around how can I incentivize any sex-text arbitrage to be provided in like all of that surplus to be just provided to whatever solving network or solving ecosystem I'm running. So whoever is capturing the arbitrage of chain, just like that I incentivize him enough to just give me that in on chain. I rather build that incentive mechanism. I guess that's what Galen is inferring, rather than entering the game myself. And yeah.
Makes sense. One question I always had was, if it weren't for a lack of order flow, what was the single biggest reason why you might refuse or not integrate with an order flow originator? What are the key technical or otherwise reasons why you might not solve for someone, aside from obviously lack of volume?
Yeah, today's order flow. So I won't say anything else because that's all that matters.
Yeah.
Like, I'm not going to invest time on like building an integration that won't from bring, and that's broken. Like, that's completely broken.
How so?
I mean, you are new to the app, was already mentioned. You are new to the app. Solve compute is what you need if you want to express intent and you want to like enter in this new paradigm in settling on chain. But you don't have order flow. How do you attract solve compute? So that's a problem today. It's just hard to tap into that, into those capabilities and attract whoever is going to be. I mean, you need to be very well funded. So CausaApp is an example. They invested millions of dollars a year financing solvers. That's going to change. I mean, that's also the idea behind what we are building. I guess we have 3 people here kind of building with that ethos. I think it's going to change in the next 1-2 years. It's just, it took time to evolve into that. So you saw CausaApp being that first like idea, in, like let's use solvers for the good on this side of the equation, and now it's evolution into like, now let's try to like not have it all behind one DApp, but make sure that every DApp can tap into that, and that's it. Yeah.
Yeah, I mean, we talked about solvers and intent apps and developer building intent apps, especially in the early stage. And what we find out is it's actually a mismatch between both sides, right? So the intent application developers, most people that we talk to, like, because people want to build intent apps mostly because, closer to the user, give a good UX and whatnot. A lot of people we talk to, they don't want to build solvers because it's too much, and then it's a small team and whatnot, and that's also not their expertise. So they want to work with solvers, but then like they don't have order flow. They're just starting, right? So it's really difficult for them to, or for a solver to justify the expense to just make a commitment and integrate them, and so they're struggling. And then on the solver side, it's the same because there are also a lot of chains, coming up. A lot of sort of smaller order flow sources are beginning, but the integration with all the sources to modify your infrastructure and integrate with everything, all the different flows. Some will require bonding their tokens. Some require a different, auction mechanism and whatnot. It's difficult. The expense is very high. So I mean, this is what we'll try to play. Sort of in the middle and the matchmaking, right? So for both sides to say, if you're an intent application developer, you don't have to build your solver, and then you can integrate with us, and then we can also integrate with every solver for each solver to express what they are able to solve, what they are able to, what type of use cases they're able to do, and then if they're missing parts, you can, sort of build your own missing piece of the puzzle yourself. But if you're just doing cross-chain trading and some of the more typical solving cases, then we likely have everybody. Somebody integrate with us will have that for you, right? And for the solver as well, right? To say, instead of sort of integrate yourself compatible into call swap, bonding token, UniX, and do go to 10 different chains. We have other solvers that are actually already working on these chains, and then they can help you partially settle, or you can propose solutions, abstract solution, and these solvers can help you settle into these networks. They can do the last mile for you, right? So this is what we try to stitch together most of the demand and supply side, I think. It will definitely help. We hope to help sort of getting the smaller guys to start and also alleviate the burden from solvers.
Yeah, I mean, order flow time, brand as well. If it's a large project, yeah, happy to support. The thing we realized very early on, we don't want to build a continuous dev shop for listening to order flow, i.e. we don't want to hire X amount of devs to integrate 50 intent networks and maybe another 50 come, maybe another 500 come. It doesn't scale. So what we actually say now is just use our API. Push and pull. You can directly use it. You can handle whatever the way you want instead of your auction, and you can just call our API. That's how we prefer this nowadays. We obviously do make some exceptions, but we're supporting, I think, around 37, 38 projects as of today, and we're listening to one, and that's CowSwap. The rest are direct API calls. Means we do not need to spend that much time on the integrations.
Super helpful. You talked, Kevin, about solvers having to make commitments to each other previously. It seems that in most of the biggest order flow originators like CowSwap or Uniswap, the solvers have to make some sort of commitment to them, the exchanges, the interfaces, whatever you want to call them. Most of the time right now, that is a commitment of trust mediated by some sort of legal, claim, or seems that might be evolving soon as we try to make the systems more permissionless, as we try to integrate economic collateral instead of just reputational collateral, maybe even consensus and cryptography at some points of the stack. Maybe that's a bit too far-fetched, but yeah, what are the ways in which you see the commitments that solvers make to the platforms that they solve on evolving over time?
Oh, that's a big question. So maybe we can make a parallel to like the TradFi world, right? So like in TradFi world, a lot of times the user just see you go to stock brokerage, you start trading stocks, but there's many layers of intermediaries sort of in that stack, right? But in the TradFi world, it's just legal documents all the way down, right? So different firm with different specializations, with different products, and then they just all have some sort of contract with each other they can enforce, and if they rug each other, they go to court. Right. Now, for crypto, obviously we don't have that, so we have to do cryptographic or proof-based systems, basically, right? So it could be cryptoeconomics, it can be cryptographic, and then like for Kalani, we do something like mathematical proofs, and it's a little bit different. But ultimately, it has to be some sort of proof-based systems, right? Because that's the only way you can enforce sort of agreement. For cryptographic, I can prove I can prove my solution to you. I can prove my computation to you. Cryptoeconomics means, okay, optimistically, this is my solution. You can check, or anybody can check later. If I'm malicious, you can slash me, right? I have a bond somewhere that covers economic damage, right? I think over time, either you talk about protocol to solver, like maybe CallSwap have a whitelist of solvers, and then they have to bond, call tokens or bond some sort of tokens, just in case they go back on their promises. So this is like protocol to solver commitment or solver to protocol commitments. Or we talk about solver to solver commitments. It's the same. It has to be one of these ways. Like Flashbots also the TEE, which has TEE also can give you proof as well. So obviously you have to trust the manufacturer, but it has to be some sort of proof system for all these parties to work together. Yeah.
If I could answer this really simply, your intent request, you're wanting an outcome, you can verify this on chain. There's view functions. You want a balance of 1,000 USDC, the address of USDC, what's the balance of? Check inside of the call data. I like the word choice of proofs, but It's really simple. It's just a view function. You're simulating call data that they're proposing and then checking the state inside of the call data. It's nothing more, nothing less, in my opinion.
I'm actually curious to hear your response, because you talked about how at the beginning you're evolving from becoming a solver to a protocol. When I think protocol, I think decentralized to some extent. Is there consensus, proofs, economic collateral? How does that play into getting solvers to make commitments to each other and their order flow originators in GlueX?
Yes, so the way it works at GlueX is we have detached, so we have divided the roles now. Like today you have a solver that is meant to do everything, not everything in the point of view of the Kalani way of us. We don't think liquidity providers are solvers. That's like we solve for liquidity providers. They want us to be solvers. They want us to work for them as solvers, optimizers. Okay, let's say next step is so solver today has to be completely enabled across the stack. So I'm running my algos, and I'm also responsible for tapping into the information that I'm going to use for solving. And so I'm the only one, of course, since I have both parts of the equation, I'm the only one that understands theoretically the solution that I've generated, right? Because I'm the only ones that are. So maybe another solver, for example, doesn't have the same information that I have, has not the same integrations to protocols, right? So now I'm being CalSwap, right? And I don't know how you generated your solution. I have no way to verify it. But I trust you are doing your bit in with, like, you know, I have some level of trust which comes through the bonding, right? So the collateral, because otherwise if you're not, I can slash you, right? So that's their like the way they handle this. And the only reason why this happens is because CalSwap has no ability to verify the solution. CalSwap doesn't know the liquidity, doesn't know the route, doesn't know any details beyond that, right? So yeah, no verification. You need to post a bond, right? GlueX, in GlueX, so we have split the roles. You have, instead of, really, we rename this, so you're not a solver, you're just an optimizer. You're just an algorithm that receives a complete search space. So at the base level, GlueX protocol consists of different modules. Okay, so a blockchain module, liquidity module, intent module, an auctioneer module, originator module, that they're open access. Everybody can contribute to that. We call them gluers, so kind of similar there. You contribute, and so the solvers are, the optimizers are optimizing on top of a known liquid space. So now when they generate that solution, they deliver that solution to GlueX protocol, the liquidity space is known. I completely understand your solution. I can verify it right away. So you don't need to post a bond to me. You just have done an optimization work. That's it. So you as an optimizer, you really have to care about the algo, finding, specializing in different intents, and making sure that your solution runs fast enough. So you worry about the speed and the detail. The verification comes naturally there because we know what they are solving with. Yeah.
It's super interesting because when I try to piece all of your different approaches together, especially as you seem to evolve from, in some cases, solver to solver marketplace of sorts, the first thing that kind of comes to mind is exchange, maybe, to some extent. Right, and that exchange can look very different, but in some shape or form, it kind of looks like that at the end of the day. To kind of like steal the question from the last panel on value accrual, I think that like if you look at most of the, let's call it revenue that goes to chains today, comes from order flow, right? The desire to bid on that order flow, the contention for state because you want to do some sort of arbitrage, and a lot of the time now that I'm seeing is that like applications are integrating your kinds of exchanges to not only improve execution quality, but more importantly, improve the user experience. And so in your mind, do you view yourselves as like stealing the value that Ethereum has captured in terms of order flow and then incorporating that into your own protocols? And if so, yeah, do you ever think about the implications that will have for like the amount people pay for like block space in general?
Yeah, no, That's actually quite spot on. So, like in theory, if everything goes well, like and this part of the narrative works, everyone here is trying to move like our at least that's how I see things. Our end game is MEV equals 0, and if MEV equals 0, at least the way in which we reward the validator or the way in which the block builder can compensate for that is different, right? It downgrade, like you don't have as much value anymore because now it's being captured somewhere else. So yeah, I guess it's gonna be interesting. Obviously, I don't think that they're just gonna die, right? We're gonna notice, okay, this really impact them, so they do need a minimum requirement to operate. So let's make sure that they have that, right? And yeah, so but yeah, probably the profits are like the idea of here is that we're gonna profit shift, like we're gonna shift the profits towards the front end of the stack. Yeah.
Yeah, I mean, my view for this is, I mean, first of all, not all order flows are equal, right? So if I give you an order just transferring my EthCC from this account to that account, it doesn't have much value, right? Nobody can extract from that. So now, so we're talking specifically about MEV, value for MEV for Ethereum or L2s and whatnot, right? The question is, does Ethereum want to capture that value, right? That is the fundamental question, right? Is it fair for a platform to, I mean, there is value to be extracted. Then the question is, okay, we know how to extract that value. Whether it's on-chain, off-chain, there's ways to extract that value, right? So the fundamental question we need to ask is, how do we redistribute that value, right? That is the fundamental question. Do you want to redistribute to users, or do you want to redistribute to stakers in the form of MEV? Or there's solvers that can provide the solutions, or auction houses that can facilitate this, right? So that is the fundamental question. I don't agree this notion of, okay, so all the the off-chain guys are just stealing the value from Ethereum, because I think infrastructure exists for a reason. Infrastructure exists to serve the users, right? So you really have to expect what the user wants. And then if the user doesn't want to be screwed, then you shouldn't just maximally screw them, extract them, right? So this is what Essential talk about as well. So given that, if we could agree with that premise, right, then value accrual, it becomes who can provide the best service to serve the users, right? So if then specifically like a value accrual, it's just going to be which part of the stack has scarcity, right? So if there are a million auction houses that compete each other to the last cent, then they probably won't accrue value, right? So if solving is super hard and then takes this much time to build, then solver will have their fair share because they need to be paid and compensated, and so value will accrue to scarcity basically in the whole stack. That would be my point of view. Yeah.
Yep. Yeah, I largely agree with what Kevin said. At the end of the day, it's a value misallocation problem. And incentives should flow to the person that creates the value. It could be the solver, it could be the user or the validator. They should not receive more or less than the value they create. A very simple example of this is LVR, which is where proposers receive value for something where they are not exposed to any risk or are contributing to the cycle in any way. So yeah, just get paid for what you do, not more, not less. And that's it.
It's a really tricky question. So I'm going to answer a different question, which is the value capture in intents.
Sounds good.
Why not? It's also tricky, right? It's not that I'm moving away to an easier question. So I was on a panel yesterday, and it was across Squid, Socket, and pretty much everyone had the view that there's value capture at every single part of the stack, but the largest value capture is at the top. They see large percentage of order flow in their whole network going through their own interfaces. Now, our personal experience is that's the complete opposite. Our interface, we done 100K volume in 2 months. Once we offered an infrastructure, we'd done 11 million in the first week. So maybe we're jaded from that experience, but I see personally more value of who can build the call data to interact with the chain itself. Like, we're positioning ourselves more as a developer tool to build intent-centric applications. that also creates some vendor lock, right? If you have full products, which we have as of today, fully relying upon us, then actually we have the value, because if we were to turn that off, then that product doesn't exist anymore. So if you're competing in an auction, yeah, probably top layer, but if you have this direct communication and full reliance upon your product, then I see that as the most value.
That's a perfect way to close it out. Everyone, please give a warm round of applause for everybody. Thank you so much for listening. Thank you so much for coming.